Hi guys, how are you? Back to our calculus 2 classes. Today we'll summarize the disk and the washer method. I'm gonna make it as easy as much, but believe me, if you finish this video, you'll see how it's gonna be easy and you're gonna master it. I spend a lot of time to prepare a table for you with all possible cases. Okay. For disk and shell method, shell method, disk for one function, disk and washer method. Disk for one function, washer for two functions. Let us start. Now, you know, we are Success Learning Systems. We're located in Clifton, New Jersey. Our phone number is this. If you have any question and you want us to help you for free, just send a text message, a picture message for this phone or an email address. Also, we have SAT online classes. Start soon, June 25. If you want to watch this, tell your friends, your families, subscribe and like our channels to receive these classes. Don't forget, please, I need you to do like and subscribe. Then calculus volume using disk and washer method. Master disk and washer method in how many? 20 minutes. Let us see. Okay. I'm going to show you what I did for you guys, just to save your time. Look here, in our class today about disk and washer method, I prepared a small table for you. We have axis of revolution, x-axis. Look here, y-axis is the same exactly. The only thing you're going to change, if we have y-axis, the only change you're going to have what? Instead of f of x, fy dy. X-axis mean y equals 0. Y-axis mean what, guys? Y-axis mean x equals 0. X equals 0. Now, if you have the limit of integration and you want you to revolve the area about x-axis and the two guys are given, the limit of the integration given, all what you have to do is just rotate it a to b fx squared. Example, look here, example for this guy, fx. I'm going to set the integration, but I will not solve it. Negative x squared plus 4 x0 and y0. That means between x-axis and y-axis in the first quadrant. In where? First quadrant. If you graph the x squared, I'm going to graph it here. If you graph x, this open up, and this 4, this is 2, negative 2, and this 2. He wanted me to revolve this guy, right? And this is 2. Okay. Then this revolving about what? X-axis. If you revolve it, this is going to be like this, and it's going to be like this. It's like half sphere. It's like half a sphere. All what you have to do, from 0 pi, from 0 to the 2, f of x negative x squared plus 4 squared dx. It's easy and simple like that. Easy and simple. Good? Now if you want y-axis, I said what? If you want y-axis for this one, look here, the same function, the same function. The same function about y-axis. And this guy 2 and this area. But now about what? Y-axis. Okay? This is 0, and we need to find this 4, right? Because the function is y equal negative x squared plus 4. When you plug 0, you get 4. Then pi. Now about y-axis. Integration from 0 to where? 4 f of y dy f y what? Squared. Now how I find f y? You solve this for y, and you need for only this area, right? You solve this for x, right? Then x squared, when you move x squared from this side to this side, becomes positive. Then x squared, and when you move the y to the other side, 4 minus y, take the square root, take what? The square root for both sides. Take the square root for both sides. Then x equal plus minus square root of 4 minus y. But here you're going to square it. Plus minus 4 minus y. Plus minus means the below and above. But actually we need the positive one, which is the one in the top, which is the plus. Even if you take any one of them, you're going to square it. Pi from 0 to the 4. Only from 0 to the 4, square root of 4. And this integration is a lot easier than the other one because the square will cancel the square root. This is the first case. You see the same thing. Then we're done with the first one. About y-axis, f of x squared about x-axis, f of y squared about what? Y-axis. Good? Just change x to fy dy. Now, the axis of revolution is now different, which is a line less than 0, not x, a line that below x-axis. This x-axis, we're going to revolve below x-axis. And one function, not two functions, that means this. F minus k square minus k square, the line, which is y equal k, could be negative 1, could be negative 3, could be negative 4, any line below x-axis. Okay. Then look here, I need to revolve x squared plus 1 negative over the interval negative 1 and 2 about y equal negative 3, which is the value of k. Then my integral will be, look here, it's easy. If you want to graph x squared plus 1, just sketch x squared plus 1 is a curve up this one and this my one, and you want to revolve it from negative 1 to the 2, from negative 1 here to the 2 here, from negative 1 to the 2. Okay, and these both blue and this the blue. This blue, this where I'll rotate. Okay, and this is my function. Then the area I want to revolve is this area about what? The line is what? Negative 3. Negative line, my line is negative 3 here. Negative 3. Negative 3. Then I need to revolve this area, x-axis, only this area. Okay, I need to revolve this area here between this curve and x equals 0, y equals 0, about this guy here. Revolve. To understand it, look here, yani, it's common sense. X squared from here to here, to understand it, let us see the common sense in this. From here to here is y. If you take any point, from here to here, to see the radius of revolution, this is y, this x and y, any point on the curve. From here to here y, and the distance from here to here, how much? We talk about distance, right? Then the radius from here to here is y plus 3. But you don't, I'm trying to make you understand what's going on. Right? Y plus what? 3. Right? The distance. Good? Which is y, what y? Y x squared y. I'm gonna put y in red. Y. And this y is x squared plus 1. X squared plus 1 plus 3, which is x squared plus 4. You see, I made it easy for you. Instead of graphing and doing x squared plus 1 minus what's k is negative 3. When you add them, becomes x squared plus 4, negative and negative positive, which is a lot easier. If you want to graph it, you can graph and see it. Y minus 3, this radius from here to here is a very big, I don't need all this area. I need all this one. If you take x squared plus 4 from here to here, minus the 3 square, which is here, look here, the negative will disappear with the square. Minus always, you see that? Minus always. Then you take x squared plus 4, which is from here to here, from any point in the curve, minus the 3, the extra piece, which is the pieces here. We don't need it, which is come from here. And pi. Okay, that's all. Then you calculate the problem. It's from negative 1 to the 2, x squared plus 4 squared minus 9, dx and pi. And this easy integral to finish it. If you have any problem with that, just please send it to me. Now, here a different case. A different case. Now, what happened here? Y is greater than 0. Like 3, like 2, like 1. Look, to understand it, I will revolve the same function. X squared plus 1. Negative 1, 2, but my line is white. Okay, 3. Look here. Let me just do it for you here, show you the radius of revolution. Now, my function, the same function, x squared plus 1, start from 1, right here, and go up, and go up. Now I have 2 lines, one here, 2 and negative 1 and 2. The first line, negative 1. The second line, 2. Okay. You don't have to graph in the test. Look here, I'm explaining for you what you have to do, but that we are true. Now, about what line? Y equal 3 is here. Okay. This is blue. And this is blue. And the line of 3 is here, 1, 2, 3. This is the line of revolution, right? The line of what? Revolution. Then this area, we need to revolve this area. Below this and this. We're going to revolve it about what? This line. You see, if you the same thing, if you take any point to see the radius of revolution, if you see the radius of revolution, if you want to see, take any point, guys, here. What this point? X and Y. Good? X and Y, this point. The Y is from here to here, right? The Y goes from here to here. Right? Good. Then, You can take this point here. The radius is increasing because that we do integration. Because that's what the rates will be increasing or decreasing. It depends from where you go from to where. From -1 to the 2. Small, big, smaller, the small radius here. These are a lot of details. Now, what we have to do, K, when we revolve, we have a big radius, which is what? The K, which is the 3, right? 3, this radius, minus what? K, what K? From here to here, K, right? Minus, if you take K minus Y, K, which is here, from here to here, which is the 3, right? The big radius, 3, minus what? Y, minus 3 minus what? Y. 3, all this, 3 minus Y, 3, the value of minus Y, give you what? Look here, 3 minus Y, all this from here to here 3, and from here to here is what? Y, give you this, minus 3 square, 9 minus this, give you the area, what you want, right? 3 minus Y. But Y is what? Y is what? 3 minus Y is x squared plus 1 in parentheses, which is 3 minus x squared minus 1, 3 square, 3 square minus 3 minus 1, what 3 minus 1? 2, right? 2 minus x squared. Good? K minus the Y. 3 minus the Y give you this piece. Right? And 3, look here, 3 minus the Y give you this small piece. 3 minus the Y give you 3. And when you do 3 square minus this, when you do 3 square from here to here, this is the 3. 3 minus this give you what we need, which is here. This is this guy here, 3 minus Y, right? And this Y to understand it, but you can apply the rule directly. You don't have to worry. This 3 minus Y, this small piece here, and this is 3 minus this now, give you what we want, which is the small, right? I make it very easy. K squared minus K minus F. That's it. Whatever number you have, 3 squared minus, look what I did here. I know the rule. 3 squared is 9, minus 3 minus the function, then you simplify it. Then that's what you have to integrate at the end. Pi from -1 to the 2, 9 minus this guy minus 2 plus x squared. All this I simplify it here. Good. Now pi and dx. How much time I have? -1 to the 2, 7 plus. How much time? Okay, good. Now, this is when we have one function revolving about x-axis. Y-axis is the same exact thing. The same. Just change what? F of x to be f of y. F of x equal f of y. F of x equal f of y. The same exact table. Okay, you can copy this table to your notes and use it all the time as well with this example. Now when we have two discs, I call this a lot easier than the other one. Washer, we call it washer method because the two radius they make something like the washer. I minimize it to see the whole table. Okay, now you can see the whole table. I think so, right? A little bit more. Yes, I think this got nice. Washer method. Marshall, when we have how many function? 2 function. The same thing, we have 3 cases, either revolving about x-axis. If I did this for x-axis, it's gonna be the same for y-axis. But instead of f of x, I'm gonna use f of y. Okay. Now, okay, this is f squared minus g squared, the top. And I believe they're here, f is, in all my cases, f is greater than what? G. I'm sorry. Good? Now we have 2 functions here, x squared. We have 1 function, right? 2 functions, one of them x and the other x squared. We need to revolve the area of these 2 functions, x squared and x, about x-axis. I'm going to show you about y-axis the same, for the same function. Look here. Look here. Look there. If you want, you can apply the rule directly. You don't have to graph. And for my student, it doesn't matter for me if they graph or not, as long as they apply it for me, right? This is x, right? And this is x squared, right? Let me just extend this line. What is this? Okay, and small eraser. And look here. 0 and 1. If you see this small area in the blue, right, and this, I'm going to give you this problem. You see that? And if you find the intersection, x squared equal x, intersection, x squared minus x equals 0, take x out, x minus 1 equals 0, then x equals 0 or x equals 1. Then I have 2 lines, right, between here and there. Another line here I'm going to put, which is x equal 1. I'm going to make it to the blue. And then this is the area I need to revolve about x-axis, right? Revolve it about what? X-axis. It's going to be like this, the same exactly in the other side. It's going to be like this, look here. And the line will be like this. And you see that? Nice shape. Nice. Zoom it. Zoom this shape. Zoom it as much as you can. Good? Good. You see that? Okay, that's the, okay, good. Done. And hold on 1 second. This is x equals 0 and this x equals 1. Now, you're still zooming it. When you revolve it about x-axis, this y equals x and this y equals x squared. The one in the top is x. Then all you have to do, pi, you see that? Pi 0 to 1, x squared minus x squared squared. Right? Which is going to be easy to integral. 0 pi x squared minus x4. Very easy integral. Very easy integration. X to the 4 dx. How much? What's the time now?
24.
24. Okay, let me just, the second case. Okay, let me just finish all of it. Now we have, look here, now, if we have, I'm gonna finish it in 4 minutes, yes, because the example is existing. Now, 2 function, and we need to revolve it for a line less than 0. Like what? Y equal -1, y equal -3. F minus k minus j if this guy is bigger. I said f is greater than g when you graph f and g. Okay, now easy. Now x squared and x, we found the intersection. Already we found the intersection, right? The revolving will be where now? About x equal what? -1. X equal what? -1. 0 to 1. This 0 to the right. And my line of revolution, x equal what? X equal -1 here, right? And the other function here, red, and the area is the same. Just zoom it, please. But the revolving will be where around what? This guy. Still, the x is bigger. Y equal x is bigger, and this y equal x squared, the lower function, the lower radius. Now, the radius of the top, x plus 1 is right, x from here to here plus 1, and this one, x squared plus 1. Minus negative is what? Do you see that? Minus and negative becomes a plus, then volume. I have to 29 minutes. Pi 0 to 1, x plus 1 square minus x squared plus 1 square dx. And you finish it. You see what is coming. The last case, when we have the function above. Back to this, x, well now about x what? Y equal 2. Y equal what? 2. Y equal 2. And then this guy will go where? Up. Y equal 2, we go take it to here. We're gonna revolve it, this area, the same area, but we're gonna revolve it where? About this function, about this line. Y equal 2. You see the radius will be, now k, look here, the last case, k minus what? K minus f, k minus j, dx. The same two function, x squared, and the top now is x, right? X, right? If the answer comes negative, you take the absolute value, 2 minus x, right? And 2 minus x squared, right? Now I think here they're gonna, the top will be, now look here, the top function, the top function will be y now, right? Because you're revolving there. Then here we're gonna change it, 2 minus x squared, and this x. 2 minus what? X squared, and here 2 minus x. To have positive answer. If you leave it the other way, it doesn't matter. Why? Look here in this case. We're gonna revolve about this line. You see this radius? This is bigger than what? From here, the distance from here to here. Zoom please, as much you can. From here to here, this y, right? 2 minus y, and this one, 2 minus x. You see this, the other guy is smaller from here to here. You see that? For the x. Okay, then after this, you finish. Now, for the y and x, it doesn't matter. Okay guys, I'm done with these two tables. I need you to review. I will not post any new question till Saturday maybe. I need you to review these two tables and send me any questions, anything you want. And don't forget to subscribe and like. Good luck guys. I did my best. Do your best by subscribing and like. Thank you and have a nice day.